Hi class, this is our second lesson in chapter 1. It's 1-2 linear measure. Yesterday we defined what a line was. A line is a straight figure made up of points and it extends infinitely in both directions that the line goes. A line segment does not extend infinitely. It has a definite start and a definite end. A line segment is part of a line with two endpoints. So yesterday, line AB, it went on forever. These arrows told us that the lines went on forever to the left and forever to the right. But this time we have segments. Segments are a measurable distance. It has a definite start and a definite stop. Yesterday we labeled a line with two letters, two capital letters. We do the exact same thing today, except yesterday, again, we had two arrows over AB. Today, we don't have those arrows because they are segments. So we label this line as line segment AB or line segment BA. And that's how it's read. It's read as segment AB or read as segment BA. So this notation at the top has a big meaning. If there's arrows, it means that it's a line. It goes on forever. If it doesn't have arrows, it means it's a segment. It has a definite start and a definite stop. When it is written as AB, it means the measure of or the length of. So if you ever see AB when it doesn't have a line over it, you assume that it means the measure of or the length of. So when it says AB is 23 feet, you assume that the measure or the length of AB is 23 feet. So if there's nothing written over the top, you assume it means the measure of. Okay, so very simple. We could take a ruler up here and we can measure this length. You've maybe had to do this before a job of your own. Maybe you take a tape measure, something like that. So here is my ruler, and we'll bring it up and we'll measure right about there. So this looks to me like it is, this segment is 1 inch, 2 inch, and not quite 3. Here is, like these longer ones are a quarter, half, 3/4. And then half of a quarter is an eighth. So this looks like to me like it is 2 inches and 1/8, 2/8, 3/8, 4/8, 5/8 of an inch long. So 2 and 5/8 inches is that segment. AB, or segment AB, is 2 and 5/8 inches. Alright, this is a big topic, so make sure you understand exactly what this means. Betweenness, when something is between, when B is between A and C, it's between if two things happen. The first thing that has to happen is all three of them have to be on the same line. A, B, and C have to be collinear. If we have 3 points like X, Y, and Z, here's X, here's Z, and if Y is down here, we would not say that X, Y, and Z are collinear. It might look like Y is in between X and Z. We might use that in our everyday language, but in geometry language, we would not say that Y is between X and Z because it's not on the same line. So one thing that has to happen is that they have to be collinear. X, Y, and Z, or A, B, and C, 3 points have to be on the same line. The second thing that has to happen is that this is called the segment addition postulate. The two pieces have to add up to equal the whole segment. So let's say, it might seem kind of basic, but let's just say this is 3 inches long, and let's say this is 8 inches long. So what it's saying here is if AB is 3 plus BC, which is 8, we have to get the total distance, which is 11. AC has to be 11. So those two properties have to be there if we're going to say something is between two other points. Okay? So here's our example where we're going to use it with other numbers now. This is where algebra kind of comes into geometry. We want to find the length of SU. Well, we would say that SU and T are collinear, and U is in between S and T. So U is in between S and T. It doesn't have to be right in between, like it doesn't have to be the exact middle spot. It's not like this is half of 45 and this is half of 45. U just has to lie somewhere on that line. So what we're going to do is, again, called the segment addition postulate. We're going to say that segment SU plus segment UT equals the whole segment ST. Okay, that makes sense, right? This distance plus this distance has to equal the total 45. So let's start filling in our numbers. SU is 5x minus 3. UT is 7x. So if I add those two segments together, I should get the full segment of 45. Now let's use algebra and let's solve for x. 5x plus 7x is 12x. I'm going to add 3 to the other side to get 12x equaling 48. I now solve by dividing both sides by 12, and I get x to equal 4. There we have it, everybody. X equals 4. And many people stop after that because they say they solve for x and they're done. We're not done, everybody. We're not done until we've solved the problem. It says find SU. So this distance right here is not 4. Okay, SU is 5 times x minus 3. So SU, that length, the length of SU is 5 times x, what was it again? 5 times x minus 3. And we found x to be 4. So it's 5 times 4 minus 3. Our answer, everybody, the length of SU is 20 minus 3, or 17. Oftentimes we label this one, there is no inches, centimeters, whatever, so we'll call it 17 units. And that, everybody, is our answer. If we wanted to, we could have found the length of UT. UT would be 7 times 4. 7 times 4 is 28. If we wanted to check our work, we would say that the two segments have to equal the total segment ST. What is 28 plus 17? The answer is 45. Okay, so our answer for this one, SU, is 17 units. Taking a look at this one, it's kind of nice to have a picture to go off of. Here, this one, we had a picture to go off of. On this next one, we aren't given a picture. But we do have knowledge of math, and we would be able to draw a picture to give us something to look at. So I would suggest that you guys draw a picture on this one. Find the value of LM if L is between N and M. So if L is between, it means that all three have to be collinear. So I'm just going to draw a line. N and M are the endpoints. So I'll put N here. I'll put M here. If you guys don't draw your picture exactly like I draw my picture, that's okay. You just have to have N and M be the endpoints, and L is in between. So L has to be somewhere in between. You can put it right here, you can put it right here, you can put it right here. It really doesn't matter as long as you put it somewhere on the line. So I'll put mine in the middle. Okay, so now let's define what we have. Here is L. It says NL is 5x. So from N to L, it's 5x. That's the measure. LM is 3x. So from here to here, it is 3x. And then we have another NL equals 15. So NL is 5x, and NL is 15. So now it's not like one segment plus the other segment equals the full segment. If NL is 5x and NL is 15, NL, that distance, is equal to itself. So 5x equals 15. Those distances are the same because it's the same segment. NL is 5x and NL is 15. So what does x have to be? That's simple enough. You divide both sides by 5 and x equals 3. Once again, you're not done yet. You're not done yet. It says find the value of LM. So I'm going to substitute this x into LM. And the measure of LM is 3 times x. And our x we found to be 3. So 3 times 3, LM is 9 units. That is the answer that you're going to have for this one. Once again, you could, solve this fully. If this one right here is now 9 units, 9 plus 15, the whole length, NM, the measure of NM, has to be 24 units. 9 plus 15. Okay. So now that brings us to the word congruent. NL right here, 5x, and NL 15, NL is congruent to itself. It's the same distance. So congruent means Same shape, same size. We use this symbol whenever we use congruent. In algebra, we use the word equals a lot. Something is equal to something else. In geometry, we use the word congruent a lot, because when two shapes are congruent, or two segments are congruent, or two angles are congruent, they have the exact same size and the exact same shape. So that's what the word congruent means. So I guess I ask you this question. Are segments AB and segment CD congruent to each other? The answer is they are. They're both the exact same length. AB is 5 inches, CD is 5 inches. So the answer is yes. And as you can see, these tick marks showed up right here. Whenever you see these tick marks right here and right here, it means that two segments are congruent to each other. So we see that a lot in geometry. We might see a rectangle and it says this one is congruent to this one and this side is congruent to this side. So whenever you see ticks like that, it means that two lengths are congruent to each other. All right. How about this next one? Are these two segments congruent to each other? Is this red line congruent to this blue line? At first glance, we might say yes. We might say that those two lengths are congruent to each other. But if the problem doesn't specify, if it doesn't give me the ticks, or if it doesn't give me a length, like this one gave me 5 inches, this line right here might be just a little bit longer, if we were to zoom in, than this one, or vice versa. Maybe one is just a little bit longer than the other. If it doesn't tell us, there's not enough information. So if there's not enough information, we can't conclude they're congruent unless the information says that we can. Okay? So congruent is a big term. We're going to be using that a lot this trimester, a lot in geometry, so it's a good term to understand. Let me know if you have any questions when you get to class tomorrow.